So let's talk about the data selection for the control charting. And I've added a little bit of text to this that's not in your handout. This is the purpose of the control chart assignment. So it's threefold. We're going to learn about the difference between continuously variable data and category or digitized rounded data. Now notice this continuous does not mean continuous in time. Okay, and that's one, everybody pay attention, look at me. It's not talking about time. Like this gives data continuously on a day-to-day basis, right? That's not what continuous means. Continuous means that between these 2 points, there's an infinite number of possibilities, okay? As opposed to like gasoline prices that are rounded to the penny. So between these 2 points, there may be only 3 possibilities. Okay, that's discrete data. So we're talking about discrete versus continuous. That's what we mean. And so that's just the one thing that makes me sad. We go through the whole semester and then I'm reading the quality reports and I see people like, this data is appropriate because it's continuous. I get a reading every day. And I was like, no, that's not what we're talking about. We're talking about the possible variability of the data. That's why it's continuously variable. It can jump around an infinite amount of times. Now we still round it maybe to 3 or 4 significant digits, but still it's got an infinite number of possibilities. That's what we mean by continuous. And I remember if you remember from CHEM 1, there was a line spectra, which was not continuous, it was discrete. And then the solar spectrum, or the black body radiation curve, we had some light at every wavelength. That was a continuum. It was continuous. It was a full rainbow. It wasn't just individual little lines from the atomic spectra. So again, that's another example of discrete versus a continuum. So our data has to be a continuum. And also we're going to demonstrate the meticulous skill of monitoring a process daily for 15 weeks. This, from alumni that have gone out into the real world, they have said this was the one exercise in all of their chemistry career that really applied directly to their job. Because you get into a lab that's regimented and you've got certain tasks that you run every day. And so this is a really good exercise. They said, don't ever drop the control chart exercise. So that made me feel good. Then also we're going to exercise or experience the benefits of data-generated action in contrast to calendar-generated action. So these 3 goals will be in the introduction to your quality report. You'll say the goal of this quality exercise, control chart exercise was blah, blah, blah. So this area, this is one example where it's not plagiarism because we know where this came from, but this is what you're going to put in your report in that introduction. The real question is, do you understand what these words mean, like the continuous thing? Okay. So here's an example of a beautiful control chart. Look how it's formatted. You know, there's every day is there, but you can't, I mean, if we were to like put a label on every day, all the little date labels would be crammed on top of each other. And so you need to figure out how to have it just put a label and then skip 6 days and then put a label on the 7th day and skip 6 and put a label on the 7th. So you can figure that out in Excel. This is a line chart, not an XY scatter chart. Even though it kind of looks like an XY scatter, the horizontal category is dates. So it's not plotting the dates by some numerical values, it's plotting them in order chronologically. So in Excel, when you're picking the type of chart, it's a line chart, not an XY scatter. In all of CHEM, I told you, don't ever use a line chart, use XY scatter, because we had X data and Y data. But in this case, we have category data. This is a category, the dates. And so you put a line chart where you have category axis and then data axis. Now I include the connecting line just to provide a visual for the data going up and down. And then you have this green region, which is called the training period. So we're going to collect data for 3 weeks. We're going to have 15 days of data. And that is a training of our, how you would say it, of our understanding of the process. We're kind of training our expectations, okay? So we want to find out what the mean of the data is and what the standard deviation is. And over 15 days, that's a population of data points. So we should have a good feel for how the process behaves after 15 days. And then we lock that mean in, and we lock that standard deviation in, and we don't calculate it anymore. We want to see if the process maintains that same behavior for the rest of the semester. So we have the training period and the control period. So we're trying to see if it stays in control as it was in the training period. So we got to learn about the process, and then we see if it is a process that's stable over time. Now the watch and action limits, the watch limits are set at 1 standard deviation from the mean, and the action limits are 2 standard deviations from the mean. And so the plus or minus 2 sigma captures 95% of the variability if it's random variability. So we should have 1 data point out of that action limit, maybe 1 out of every 20 times, so 5%. You know, after 20 measurements, you're probably going to have 1 data point that's outside that limit if it's perfectly normally distributed. Here we have 4 data points that are outside. So every data point beyond the action limit must trigger an action. Now, if this was a gas chromatograph and our retention time was bouncing around randomly, but then one day it was really short, okay, that means it came out fast. And so what is our action? Well, our action is to explore, did the flow rate change? Maybe the flow rate was faster, and so it came out in a shorter retention time. Maybe the heat, the temperature control was off, and it was hotter, so it came out faster. So there's a lot of things that can affect that. But we would take the action by exploring our equipment or our process. But if it's in control, we don't have to do that, because it seems like nothing's changed. It's still behaving like it did historically. So we wouldn't waste all that time. But if it's off, then we know, well, I can't run these samples yet because something's wrong with my GC. So you got to explore, reset the heat, reset the oven, run your sample again. If it comes out in control, okay, then you can proceed with your work. And I want your chart to look just like this, where like you have the data in green for the training period, I mean really, and the black control period, and then the red action lines, the orange is the watch lines, and the green is the mean. So I mean, you're just basically going to try to reproduce this exact thing. So you're going to learn how to format all of those. Now, how do you get these points green and those points black? You plot them all in black first, and then you plot just the first 15 in green and stick it on the same chart, and they're on top. Okay, so it's real easy. There's a black dot underneath this green dot, but you just can't see it because it's exactly the same number. Okay, so no problem. Okay, so now the triangles, you don't have to do these red triangles. I did that later in the PowerPoint. So let me, this is a new slide, it's not in your notes, but I just want to pound home this idea of continuous versus discrete, okay? And also the idea that a control chart is a data point that doesn't change. So look at this up here. That data point wants to have the same mean the whole time. The only reason it's changing is some unknown random fluctuation. So you're trying to pick something that doesn't change. As we go from, I hope, right now in January to May, temperature changes. I hope temperature goes up because I'm cold. Okay, so temperature is not a good variable to use because it's not constant. It has a natural trend. So we don't want to use data that trends. We want to use data that doesn't trend. Now, the day-to-day temperature change, that fluctuates around 0. One day it'll go up by 5 degrees. The next day we have a little cold front come through. It goes down by 10 degrees and so on. So daily differences in temperature are okay. Because what are we doing? We're taking the differences. We're taking a sloped line and we're taking the slope, right? The change in rise over run. The run is 1 day. So the rise, we're subtracting that and we're taking out the slope. So we're just plotting the data by subtracting the slope. So daily differences work. And so that's a very common one to do. You can do daily differences of temperature here in Huntsville. You could, if you have a hometown, some other place, you could do that and keep track of hots and colds on a daily basis, daily change basis. But so you would just plot the temperature, and then you'd have a column that was the difference, and that would be an okay one to do. So it must be a numerical result that does not change over time. You understand what I mean by not change? It's going to be randomly changing, but it's going to have the same mean all the way through the semester. Okay, it must be continuous, meaning there's an infinite number of potential results within the window of measurement. Okay, this is required because we're taking the average and standard deviation, and normal statistics, like our 95% confidence intervals and everything, are assuming you have continuous data. If you don't have continuous data, those assumptions fail. So that's why we need continuous data. And this assumption fails with discrete data. So here's an example of discrete data. This is gas prices. Well, I have flow rate, but it was gas prices. I don't know. But this is discrete data. Do you see that in the window of measurement, the vertical axis, there's not an infinite number of results? Not even close. There's 4 results. Okay, and it hops from one to the other. And so if you were to take look how many data points are out of control above that red line. It's ridiculous, isn't it? And that's because it's not continuous data. Is this system really out of control that many times? No, it's not. And so you can't use data that looks like this. So if you have that's why gas prices are not good, because they don't change very often. Like it might be the same price 3 days in a row. Well, that's not statistically valid either. What you're doing is you're missing they're rounding it off, and you're missing the actual fluctuation. Now, if you want to do you're just really focused on gasoline. That's your thing. Okay. Then you could do the national average, and you could do a daily difference of the national average of gas prices, because that will fluctuate day to day, be somewhat continuous, and a daily difference will take out any kind of slope that you have. Stock prices, the stock market wants to grow or go down. So again, daily differences of stocks is okay, but tracking a stock price, it's going to trend like crazy and not be in control. So because our statistical models are based on continuous data, we have to have continuous data. What's wrong with this one? It's trending. That's a trend, and that's not in control. Okay, if you take the daily difference, then it'll be a mean close to 0 and irregular fluctuations up and down. So this is sloping data. It's not in control. So you must choose a data source that doesn't slope up or down with time. And sometimes your data, we had a person tracking, I think it was Yamaha motorcycle stock prices or something like that, and a Japanese motorcycle company, and the Fukushima meltdown, an earthquake and tsunami in Japan happened, and they stopped trading their stocks for a week. Okay. But that's okay. His data was out of control. Like he's going along, statistical variation, and it was like bing, bing, and then nothing. You're like, what happened? Well, in his little control log, it's like, yeah, earthquake, a tsunami, a nuclear meltdown. Pretty easy to find what caused his data to go out of control, Now, sometimes people want to do something that requires an enormous amount of personal discipline. Okay. Like I'm going to take my daily weight, or I'm going to take my food intake, or something like that. If you're really disciplined, then yeah, I'll approve that. But I'm going to give you some pushback on that, because I don't want you to say, oh, I forgot on Tuesday. Oh, I forgot on Wednesday, and do that all through the semester. And you got a bunch of gaps in your data. Okay. I was real skeptical of this one, but it turned out to be a great control chart. Every morning she had to take her little dog out to pee, and she wanted to time the time it took her dog to find a spot. Okay. Yeah, Brittany. Yes, this is Brittany. I was like, "Are you sure?" She's like, "I have to do it every day. The dog will pee in my apartment if I don't." So I was like, "Okay, I guess there's a check there that's motivating you to do this every day." And so she would go out there. So I spent the whole semester looking at data on her dog, trying to find a spot to pee. But it's it's going along. It's a pretty regular dog. 20 seconds, no problem. And then it'd be like a minute and a half, and it'd be way out of control. And she's like, in her control log, it says, high measurement, neighbor was walking by, dog had to bark, So it was really a fun one to follow. And it was very clear with her research. Like, she's like, what happened? This was out of control. Well, yeah, the person was walking by and they're barking at them, not doing their business. So it was pretty fun. So you can be creative, but I would say within reason. I want to make sure that you're successful in collecting the data. And it needs to be something you can research. So stuff that's on the internet is really good. Like if you have a stock price and it goes out of control on a daily difference, you can probably pull Yahoo Finance or something like that, Google Finance, and find what's going on with that stock. So I like stocks. They're pretty easy to track. Again, the focus isn't necessarily what you track, it's the discipline of doing it and then writing the report and then knowing when to make an action. When it goes out of control, you do your research. You have a little log that says the data went out on this day and here's the result of my research and here's the URL where I found the data that I'm talking about. So you need to decide what process you're going to monitor. Temperature's bad, but daily change is good. But this is how you need to calculate the daily change. So in your data table, you got the dates, you got the times. And let's say I enter the data for today. I need to subtract yesterday from today. And it's in this order. When I say I'm subtracting yesterday from today, the minus sign is in front of yesterday. Many students get that flipped. And so the reason you don't want to flip it, and the reason I'm really focused on this, is let's say the temperature dropped today and I've got this backwards, then it's going to show a positive number. Okay. Or if it went up today and I've got this backwards, it's going to show a negative number. So it's going to look like today's daily change was down when it was really up. And so don't get this backwards because I'll catch it and I'll fuss at you. Okay. So do not do this. Okay. So it's the previous, and here's how you say it in your report. The previous day's temperature was subtracted from the current day's temperature. Sometimes you get the equation right and then you say it wrong. So grammatically, you're saying yesterday was subtracted from today or the current day. Your weight is bad, but daily change is good. Because I mean, my weight fluctuates, it trends. So I'm sure yours does too. But daily change is something that can be tracked. I had a student doing that one, and all of a sudden they were, fluctuating, or they're in control, I would say. And then all of a sudden it was like boom, boom, like 2 points, negative, out of control. And I was like, whoa, what happened? They lost a fair bit of weight in 2 days. What's going on? I mean, not a huge amount, but it was out of control, right? So then I go to the control log and they're like, got the flu and threw up for 2 days. So they got rid of a lot of weight, and they were at both ends. And so it was substantially different mass, from their normal fluctuations. And so I thought that was interesting. Not that you need to know that, but again, gas prices just are not good because they're rounded to the penny or even the tenths of a cent, the third decimal place. But even that doesn't change. It's always 0.9, right? Or 56.9, the little 9. So that's not even a valid data point. Okay, I think that's it for the control chart. What questions do you have on it? This whole exercise. I need to approve it before you start wasting your time collecting a bunch of data. So you'll put that stuff in the spreadsheet, and there's a column here that says DW's comments. And so I'll write, are you sure you're going to track this every day? Or this is great, and I'll give you a yes. You have to have a yes in that column, the last column, to start collecting your data. I'll put up the group spreadsheet too. I need to check to see where that is, but I'll let you know. Yes. Well, after you get the yes. So this week, I'd really like for you to focus on getting that approval, getting that yes. And so then ideally, we would start next Monday. Yeah. Yes.
I assume there's no overlap. Nobody can do the same thing.
I would like for you not to. But like if you just say you're doing daily difference in temperature and you both put Huntsville in there, I was like, all right, Sammy already grabbed Huntsville. Pick a different city, And so, and don't think just temperature. You could do atmospheric pressure, daily difference in that too. There's other things. Relative humidity is tricky in that it's not necessarily reported to 3 significant figures. So that's not really a good one. It's more discrete than continuous. So I'd shy away from relative humidity. Time-based things, if they're possible, going over 24 hours are no good. So I can't think of an example of that, but there was one that was going to do that. Brittany's dog was the weirdest one, but it was fun. Okay, this one was unusual. This person gamed every day, and I cautioned them against that too. I was like, you could study, right? And they calculated how many mouse clicks they did in their games. Yeah, because they had a mouse click counter in their software or whatever, and that was amazing. I mean, you do 2 fingers? How do you do that so fast and so often? It was like 6,000 or something like that. It was crazy. Yeah, it must have been a shooter. Wazda. So anyway, that was interesting. They did all right. They made good grades, but I was just shocked. I was like, how much they play a game. Yeah. Don't let that destroy your career. Of course, you're a graduating senior, so good job. You've navigated that. But I once had a student in PChem 1 who was not just falling asleep in class. I'm used to the whole rolling their eyes, kind of. So I try to change my voice a little bit to wake you up. No, this guy was like, and so 2 or 3 times, 8 a.m. class. I mean, I know, but there's the normal sleepiness, and then there's this. And so I said, "Can you come to my office?" And he came up there, and he sat down, and I said, "All right, what game are you playing?" And he goes, "How'd you know?" I said, "Nobody falls asleep that hard in class unless they're up all night." And he goes, "Well, I'm on this World of Warcraft, guild or whatever, and all my teammates are in New Zealand and Australia, so we have to play at 3 a.m." And I was like, "Dude, how much are you paying for this class and all the other classes and your degree?" And he's like, "Oh." I said, don't do that to yourself. You're throwing away your success. And so anyway, don't let anything get between you and success. But I think you guys have gotten there. So good job. All right. That's all I have. We'll see you next time.